Hello, we are from Group 1 and we are going to present on our Lab 2, which is free and forced vortex. We have 4 group members consisting of Mirza Kadrina, Mas Rizal, Siti Aisyah Izzah, and me, Romilia. These are our contents consisting of abstract, introduction, theory, objectives, methodology, apparatus, and material, results and discussion, conclusion, recommendations, and references.
I'm going to explain on the abstract. So for the experiment was carried out to study the free and forced vortex. The objectives for free vortex experiment are to study the relationship between the surface profile and the speed. Next, for forced vortex experiment are to find the relationship between the surface profile and total height. Vortex is known as the rotation of fluid elements around a common center. There are two types of vortex, which are free and forced vortex. The free vortex experiment was first conducted by inserting an orifice of 24 mm diameter into the center exit in the tank's base. After switching on the pump, the control valve was slowly opened and ensure the water level is maintained until it reached a stable state. The profile measuring gauge was used to measure the water surface profile. Therefore, surface probe was used to measure the length between the bridge and the water surface. For forced vortex experiment, two-blade pedal wheel was inserted into the center exit in the tank's base. So after switching on the pump, the control valve was slowly opened until a stable condition of water level is reached. Pitot tube was inserted at depth of 3 cm in the opposite direction of the water flow to measure the amount of water collected at different flow rate. The vortex diameter was recorded by using profile measuring gauge, and surface probes was used to measure the length between the bridge and also the water surface. Besides, the number of rotation made by pedal in 60 seconds was also recorded. Therefore, the time for water increase at different flow rate of 3 liter per minute, 6 liter per minute to 9 lpm were recorded after finishing both experiments. So the control valve was closed and the pump was switched off. Based on the results obtained and calculated, free vortex experiment shows that lower radius results in higher velocity, and velocity is proportional to radius. Meanwhile, forced vortex shows that the angular velocity is dependent on water level and pedal's rotation in 60 seconds. The angular velocity increases when the height from the top of measuring gauge to bridge increases. For the introduction, this experiment is focusing on the analysis of fluid flow, which by means of assuming the kinematics of flow and also the patterns of fluid motion. Vortex motion is a basic flow pattern, and it is defined as motion in circular path. So there are two types of vortex or vortices. So the first one is the free vortex. Free vortex only occur when the fluid mass rotates without any external force. And the fluid mass rotates either by internal action or due to some rotation previously applied to it. Secondly, the forced vortex is caused by external forces on the fluid, such as pump impeller. So there is some external power source is applied to rotate the fluid mass. For the theory, a vortex is the rotation of fluid elements around a common center. So vortex motion is basically defined as a motion in which the whole fluid mass rotates about an axis and the mass of fluid in rotation about a fixed axis. So for as you can see, the vortex example such as tornado, vortex formation due to the operational dam, whirlwind, water drainage from sink, and so on. So there are two types of vortex flow, which are forced vortex flow and free vortex flow. The characteristics of free and forced vortex are different. So for free free vortex does not require the application of external energy for continuance, and it only produces medium spirals towards the center. While for the forced vortex, it is produced and maintained by application of external forces. So fluid circles around a center, and the example of forced vortex is when the vertical cylinder containing rotated liquid with constant angular velocity and liquid flow inside the impeller of a centrifugal pump, and also the water flow through the runner of a turbine. So this experiment is a theory about the forced vortex, flow surface shape of forced vortex, and the angular velocity of a rotating liquid in a cylindrical tank. So for the objective, free vortex and forced vortex both have different objectives. So for experiment 1, which is free vortex, the objective of this experiment is to study the surface profile and speed, and also to find a relationship between surface profile and speed. Next, for experiment 2, which is forced vortex, the objectives are to study the surface profile and angular velocity, and also to find a relationship between the surface profile and total head.
In meteorology, we have first general setup procedure. First, the water inlet pipe was connected to the water supply. Second, the pump was on and ensured the control valve was fully closed. For free vortex, we have 9 procedures that we need to know. Number 1, the orifice with a diameter of 24 mm was inserted into the center exit in the tank bags. Number 2, a vessel with a diameter of 9 mm was used. Number 3, the pump was on and ensured the control valve was fully closed. Number 4, before the water overflow, the control valve was slowly opened and the flow of water was controlled. Number 5, the water level was maintained until it reached a stable state. Number 6, after reaching a constant water level, the profile measuring gauge and surface probes were lowered into the tank until it close to the water surface. The water surface profile was measured by adjusting the profile measuring gauge to a suitable radius. For the surface probe, the length between the bridge and the water surface were measured. Number 7, there were 3 holes for the surface probe with the following distance from the center: 30 mm, 70 mm, and 110 mm, while the center is for the profile measuring gauge. Number 8, the diameter of Vortex was recorded by using the profile measuring gauge, surface probes, and the height of the profile measuring gauge from the vortex to the bridge. Number 9, after the measurements were completed, the control valve was closed, the pump was turned off, the apparatus was drained, and the procedure was repeated using a vessel of 12.5 mm. For forced vortex, it had 9 procedures. Number 1, 3 points were marked for the water level: high, medium, and low. Number 2, the 2 blade pedal wheel were inserted into the center exit in the tank base. Number 3, the pump was on. Number 4, before the water overflow, the center valve was slowly opened and the flow of water was controlled. The tank was filled with water until it reached the height level. Number 5, after reaching a stable water level, the profile measuring gauge and surface probes were lowered into the tank until it close to the water surface. The water surface profile was measured by adjusting the profile measuring gauge to a suitable radius. For the surface probe, the length between the bridge and the water surface was measured. There were 3 holes for the surface probe with the following distance from the center: 30 mm, 70 mm, and 110 mm, while the center is for the profile measuring gauge. Number 6, after that, pitot tube was inserted into the water at the depth 3 cm. Make sure to place the pitot tube in the opposite direction of the water flow so that water can enter the pitot tube. The amount of water entered the pitot tube was measured. Number 7, the diameter of vortex was recorded by using the profile measuring gauge, surface probes, the height of profile measuring gauge for the vortex to the bridge, and how many rotations the pedal makes in 60 seconds. Number 8. After the data was recorded, close the sinkhole and recorded the time of water increase from 3 lpm, 6 lpm to 9 lpm at the LPM apparatus beside the sink. Number 9. After the measurements were completed, the control valve was closed, the pump was turned off, the apparatus was drained, and the procedure was repeated using a vessel of 12.5 mm. For general shutdown procedure, it have 4 procedures. Number 1. After the experiment finished, the control valve and the pump were closed. Number 2. All the valves were open to drain the water inside the tank. Number 3. All the orifices and the 2-blade pedal from inside the tank were removed. Number 4. All apparatus such as orifice, 2-blade pedal, the profile measuring gauge, survey props, and ruler were arranged. For the experiment, we used the free and forced vortex apparatus F123. This consists of a cylindrical vessel having 2 pairs of diametrically opposed inlet tubes. These are the apparatus we used in this experiment: pump switch, control valve, profile measuring gauge, surface probe, nozzle. We have 2 nozzles that we use. First is 9 mm and the second one is 12.5 mm. Bridge, pedal, ruler, and heater tube.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mirza Kadrina. I will be presenting about the result and discussion. The experiment will manage to finish because of the objective of this experiment to investigate the physical phenomena associated with the free and forced vortex, and then to determine the relationship between the velocity and angular velocity for free vortex and forced vortex respectively with the vortex surface profile. The first experiment was deal with the free vortex. In this experiment, 4 different sizes of orifice diameters such as 8, 12, 16, and 24 millimeters were used to calculate the velocity for each. From experiment, the bigger size of orifice diameter will give a greater shape of vortex. This was because the vortex created depends on the diameter of orifice. The diameter at center, height from top of profile measuring gauge to bridge, and pitot head tube difference were obtained during experiment. The distance from bridge to water surface for all orifice diameter was 206 millimeters due to the same water level that used. These all data were used to get the value of the theoretical and experimental velocity. On this slide, show the value of the pressure head X were obtained by using the formula X equal to profile measuring gauge whole length minus measuring height minus width A, which accounts 206 millimeters. The radius also were obtained. In order to calculate the experimental velocity, it used the relationship of pitot head tube difference and gravity. This was because the theory said that using the appropriate pitot tube provided, the velocity at any point in the free vortex could be measured. For example, on this slide show how to calculate the velocity experiment of orifice diameter 24 millimeters. In order to calculate the theoretical velocity, the slope of curve between pressure head and inverse radius square, or known as a gradient calculated, was required as in graph 1, which accounts 1.75 millimeters square in order to get the value of the constant. As the depth increases, the radius of the vortex decreases. From value K that accounts 185.30 millimeters square per second, the calculated velocity can be determined by using equation velocity equals to constant per radius. As in table 2, it shown the theoretical and experimental velocity for 24, 16, 12, and 8 millimeters, which were accounts 6.86, 11.23, 18.53 and 28.51 for theoretical velocity, while for experimental velocity were accounts 198.09, 242.61, 262.05, and 280.14. The unit involved was millimeter per second. The data obtained were different due to the different equation used. From this all data, it can be concluded that the lower radius result on the higher velocity. This was because the velocity was inversely proportional to radius in every case as in graph 2. Therefore, the result were obeying the theory. Graph 3 show the velocity versus surface profile in free vortex experiment. This can be proven by its illustration on my right hand side, which show the velocity profile for free vortex. The second experiment was observed the force vortex. In this experiment, the pedal which act as a stirrer of flow strengthener and spin on a stud mounted on a bar-shaped plug put in the center orifice. The pedal which was at the bottom of the cylinder was used to create a force vortex on the water surface that rotated by water jets. This was because in order to create force vortex flow, the external torque such as rotating motion or known as a pedal was required to rotate the fluid mass. In this experiment, 3 different water levels inside the cylinder were used, such as high, medium, and low water level. The 3 different water levels gave different results on height from top of measuring gauge to bridge and LPM. The profile of force vortex was determined using a bridge piece with the measuring needles. The time taken for water to reach 3 liter flow rate were 1.16 minutes, 1.05 minutes, and 1.07 minutes, which result on 2.59 LPM, 2.86 LPM, and 2.80 LPM for first, second, and third trial. For first trial, height measure was 115, 160 mm, 180 mm, and 120 millimeters. For second trial, height measure was 92 mm, 93 mm, 95 mm, and 97 mm. For third trial, height measure was 58 mm, 91 mm, 91 mm, and 92 mm. As in table 3, the height from top of measuring gauge to bridge increased. The angular velocity also increased. The angular velocity can be determined by using formula below. Angular velocity equals to 2 pi multiplied with the number of revolution over 60 seconds. The data of angular velocity for first, second, and third trial were 1.57, 1.36, and 1.26 rad per second. The different value of the angular velocity were due to the different number of the revolution in 60 seconds as shown in table 3, which for first, second, and third trial were 15, 13, and 12 rotating of circle. It can be concluded that the angular velocity was dependent on water level and the impeller rotation per 60 seconds. Angular velocity was proportional to surface profile for force vortex as figured on velocity profile for force vortex. It can be proven from equation z equals to angular velocity square radius square over with the 2 gravity. The surface profile of a force vortex flow was parabolic. In order to calculate the theoretical height, it used this formula: height equals to HO plus angular velocity square multiplied with the radius square over 2 gravity. As in table 3, it can be seen that the measure and theoretical height from the top of measuring gauge to bridge for 3 trials were slightly different. This may due to the human errors when conducting the experiment. From graph 4, 5, and 6, it's shown that if the distance from center increased, the height also increased. Graph 4, 5, and 6 show the vortex profile for each trials. As in graph 4, 5, and 6, the major slope gradient of the first, second, and third trial was 0.0462, 0.0462, and 0.0313 respectively, while the theoretical slope gradient was 0.0708, 0.0621, and 0.0403. There were some factors affecting the accuracy of the result. During the experiment began, the velocity of water that coming out from the nozzle with 12.5 and 9.0 millimeter diameter were not same at two positions that caused the shape of vortex was not in the center position, which made harder to measure the vortex by using the profile measuring gauge. Next, having some error during the procedure that needs to stop water flowing out from the volumetric tank into the sump tank in the hydraulic bench. Sometimes a little bit of water coming out due to the particular hole that gives chance to the water flowing down. Lastly, the parallax error, which the observer eye position was not parallel to the scale reading on the pitot tube.
In conclusion, for experiment 1, which is the free vortex, so based on the result recorded, it can conclude that the smaller the radius, the greater the velocity occur on the vortex. It can be proved by water profile that the highest velocity that was calculated was 280.14 mm per second and the lowest velocity was 198.09 mm per second. So by using the equation of velocity, it is known that the velocity is inversely proportional to the radius. Thus, velocity is increased as the radius decreases. As for the shape of the vortex, the larger the diameter of the orifice meter, the larger the vortex on surface profile. Thus, the objective were achieved on this experiment 1. As for the experiment 2, which is the force vortex, the objective was to study the surface profile of force vortex and its relationship with angular velocity. It can be concluded that the angular velocity is dependent on water level and the rotation in 60 seconds. So from the result on the three different water level, which is the high, medium and low, it can be said that the angular velocity is influenced by the head from top of measuring gauge to bridge. So as the height from top of measuring gauge to bridge increase, the angular velocity also be increased. As for the shape profile of the vortex, force vortex, from the result it was known as the parabolic. Thus, the objective of this experiment 2 is achieved. So now we're going to have the recommendation of the lab 2 free force vortex. The first recommendation that we want to include in our experiment is the first one, the flow that coming out from 12.5 and 9.0 millimeter nozzle should be fixed in order to get the constant velocity and to make sure that the vortex is at the center position. So second one, all group members should be discuss all the procedure before start up the experiment so that the experiment can be conducted efficiently. So the third one, the observer to take the reading should be more than 1% so that the reading can be obtained accurately. So last but not least, and when taking the shape vortex using the measuring gauge, it needs to be avoid touching the surface of the water so that the shape of vortex can be determined accurately. And that will be all from recommendation and our presentation lab report, and thank you.